Feeders supplying power to a swimming pool subpanel within a single-family dwelling do not necessarily mandate the use of conduit for the section traversing the attic space from the main electrical panel. The electrical codes typically permit the utilization of either conduit or sheathed cable, offering flexibility in installation methods. The decision to employ conduit versus sheathed cable may hinge on several factors, including local regulations, the specific type of sheathed cable, and the environmental conditions prevalent within the attic. Conduit, generally constructed from metal or rigid polyvinyl chloride, provides a robust physical barrier, shielding conductors from potential damage and environmental factors. This is particularly advantageous in attics prone to physical stress, moisture, or extreme temperature variations. Furthermore, conduit offers enhanced protection against rodent intrusion and other forms of physical compromise. When opting for conduit, it is essential to ensure proper grounding and bonding of the conduit system, maintaining electrical safety throughout the installation. Sheathed cable, such as non-metallic sheathed cable, also known as Type NMB cable, presents an alternative wiring method suitable for dry locations. Type NMB cable consists of two or more insulated conductors encased within a non-metallic outer jacket, providing a degree of mechanical protection. However, it is crucial to verify that the specific type of sheathed cable employed is approved for use in attic environments and complies with all applicable codes and standards. Factors to consider when using sheathed cable include the cable's temperature rating, its resistance to moisture, and its ability to withstand physical stress. In instances where the attic environment is particularly harsh or demanding, conduit may represent the more prudent choice, offering superior protection and long-term reliability. Conversely, in milder attic conditions, sheathed cable can provide a cost-effective and readily installed wiring solution. Ultimately, the selection between conduit and sheathed cable should be guided by a comprehensive assessment of the specific installation parameters, taking into account local codes, environmental factors, and the desired level of protection for the electrical conductors. Regardless of the wiring method chosen, it is paramount to adhere to all applicable electrical codes and standards, ensuring a safe and compliant installation. This includes proper sizing of conductors, appropriate overcurrent protection, and adherence to grounding and bonding requirements. It is also recommended to consult with a qualified electrician to determine the most suitable wiring method for the specific application and to ensure that the installation is performed in accordance with best practices. When dealing with electrical installations related to swimming pools, there are specific safety considerations to keep in mind. Section 680 of the National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in and around swimming pools, hot tubs, and similar aquatic environments. This section addresses topics such as bonding, grounding, equipotential planes, and the proper selection and installation of electrical equipment. Bonding refers to the practice of connecting all metallic parts of the pool structure and associated equipment to create an electrically continuous system. This helps to minimize voltage gradients in the pool area and reduce the risk of electric shock. Grounding involves connecting the electrical system to earth, providing a path for fault current to flow back to the source, tripping the overcurrent protective device and energizing the circuit. An equipotential plane is a grid of conductive material installed beneath the pool deck or surrounding area, providing a low impedance path for fault current and further minimizing voltage gradients. When installing feeders to a swimming pool subpanel, it is important to ensure that the wiring method is suitable for the environment. If the feeders are run underground, they should be installed in conduit that is approved for direct burial. If the feeders are run above ground, they should be protected from physical damage and exposure to the elements. The subpanel itself should be located at least 5 feet, or 1.5 meters, from the inside wall of the pool, unless it is separated from the pool by a permanent barrier. The subpanel should also be equipped with a ground fault circuit interrupter, or GFCI, to protect against electric shock. All electrical equipment associated with the swimming pool, including pumps, filters, and lighting fixtures, must be listed and labeled for use in wet locations. These devices should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. It is also important to ensure that all electrical connections are properly made and protected from moisture. Regular inspections and maintenance of the electrical system are essential to ensure its continued safety and reliability. Any damaged or deteriorated components should be replaced promptly. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation or repair. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electric shock. Here are some additional considerations for running feeders to a swimming pool subpanel in an attic. Firstly, consider the ambient temperature of the attic. Attics can get very hot, especially during the summer months. It is important to use conductors and wiring methods that are rated for the maximum ambient temperature of the attic. Secondly, protect the conductors from physical damage. Attics can be dusty and dirty, and there is a risk of the conductors being damaged by rodents or other pests. It is important to protect the conductors by running them in conduit or using a cable assembly that is designed for use in attics. Thirdly, ensure that the conductors are properly supported. Conductors should be supported at regular intervals to prevent them from sagging or coming into contact with other objects. The support spacing should be in accordance with the manufacturer's instructions and all applicable codes and standards. Fourthly, provide adequate access to the conductors for inspection and maintenance. It is important to be able to easily access the conductors for inspection and maintenance. This can be accomplished by installing access panels or using a wiring method that allows for easy removal of the conductors. Fifthly, label all conductors clearly. All conductors should be labeled clearly to identify their purpose. This will help to prevent confusion and make it easier to troubleshoot problems. Sixthly, use appropriate grounding and bonding techniques. Grounding and bonding are essential for electrical safety. It is important to use appropriate grounding and bonding techniques to ensure that the electrical system is properly grounded and bonded. This will help to minimize the risk of electric shock. Seventhly, install ground fault circuit interrupters. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits that serve swimming pools. GFCIs protect against electric shock by detecting ground faults and interrupting the circuit. It is important to install GFCIs in accordance with the manufacturer's instructions and all applicable codes and standards. Eighthly, follow all applicable codes and standards. All electrical installations must comply with all applicable codes and standards. It is important to familiarize yourself with the codes and standards that apply to your project before you begin work. If you are not sure whether your installation complies with the codes and standards, you should consult with a qualified electrician. Ninthly, obtain the necessary permits. In many jurisdictions, it is necessary to obtain a permit before performing electrical work. It is important to obtain all necessary permits before you begin work. This will help to ensure that your installation complies with the codes and standards and that it is inspected by a qualified inspector. Tenthly, hire a qualified electrician. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to perform the work safely and correctly. They will also be familiar with the codes and standards that apply to your project. When selecting an electrician, it is important to check their credentials and references. Make sure that they are licensed and insured. You should also ask them for a written estimate before you begin work. The estimate should include the cost of labor, materials, and permits. Finally, always follow the electrician's instructions carefully. They are the experts, and they will be able to guide you through the process safely and correctly. Remember that electrical work can be dangerous. It is important to take all necessary precautions to avoid electric shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. In addition to the above considerations, it is also important to be aware of the specific requirements of the National Electrical Code, or NEC, for swimming pool installations. The NEC provides detailed guidelines for electrical installations in and around swimming pools, hot tubs, and similar aquatic environments. It is important to familiarize yourself with the NEC requirements before you begin work. Some of the key NEC requirements for swimming pool installations include bonding all metallic parts of the pool structure and associated equipment, grounding the electrical system, installing an equipotential plane beneath the pool deck or surrounding area, using listed and labeled equipment for wet locations, protecting electrical connections from moisture, and installing ground fault circuit interrupters. It is also important to be aware of the requirements for underwater lighting. Underwater lighting fixtures must be specifically listed for use in swimming pools and must be installed in accordance with the manufacturer's instructions and all applicable codes and standards. The fixtures must be grounded and bonded, and they must be protected by a ground fault circuit interrupter. In addition to the NEC requirements, there may also be local codes and standards that apply to swimming pool installations. It is important to check with your local building department to determine what the specific requirements are in your area. By following all applicable codes and standards and taking all necessary precautions, you can help to ensure that your swimming pool electrical installation is safe and compliant. The determination of whether to use conduit or sheathed cable for feeders to a swimming pool subpanel in a single-family home ultimately depends on a variety of factors, including local codes, environmental conditions, and personal preference. However, it is important to remember that both wiring methods are acceptable under the NEC, provided that they are installed in accordance with all applicable requirements. Always prioritize safety and consult with a qualified electrician to ensure safe and compliant installation.